Hi friends, welcome all. In this video, we are going to discuss a question related with gradient function. And the question is, assume f and g are differentiable functions of two variables. Then prove that gradient of fg is equal to f into gradient of g plus g into gradient of f. Actually, this is the property of gradient vectors, and this rule is called product rule of gradient function. Product rule of gradient function. Similarly, quotient rule of gradient function. What is the quotient rule of gradient function? Del of f by g is equal to f del g, g del f minus f del g whole divided by g square, and sum rule and difference rule is given by del of gradient of f plus g or f minus g is given by gradient of f plus or minus gradient of g, and scalar multiple rule. C is a scalar, then gradient of cf is given by c into gradient of f. This rule is called quotient rule for gradient function, and this rule is sum rule or difference rule for gradient function, and del of gradient of cf equal to c into del f. This property is scalar multiple rule for gradient function. Through this question, we are proving the sum rule for gradient function. Similarly, we can prove that the quotient rule, the sum rule, the product rule for gradient function. Similarly, we can prove that the quotient rule, the sum rule, the difference rule, and the constant multiple rule. So here we have to prove that the gradient of fg is equal to f into gradient of g plus g into gradient of f. What is gradient of fg? By definition, it is given by dou by dou x of fg into I cap plus dou by dou y of fg into j cap. Fg is a simple function, f into g, let it be some h. Then gradient of h is given by the partial derivative of h with respect to x and the partial derivative of h with respect to y. Here the h is f into g. Now, by product rule for partial derivatives, we have the partial derivative of fg with respect to x is given by f into partial derivative of g with respect to x plus g into partial derivative of f with respect to x into I cap plus, and similarly the partial derivative of fg, the product rule for partial derivative, usual derivatives, the partial derivative of fg with respect to y is given by f into partial derivative of g with respect to y plus g into partial derivative of f with respect to I into j cap. That is equal to, collect the terms containing I, here f into the partial derivative of g with respect to x, here also f into partial derivative of g with respect to y. Though these two terms contains the term f as a common factor, therefore if we are arranging this term, we have f into partial derivative of g with respect to x into I cap plus f into partial derivative of g with respect to y into j cap. These two terms are added. Now the remaining two terms are g into the partial derivative of f with respect to x I cap plus g into the partial derivative of f with respect to y into j cap. From these two terms, we can collect f as a common factor outside. Then we will get f into the partial derivative of g with respect to x I cap and the partial derivative of g with respect to y j cap plus g into these two terms containing the term g as a common factor. If g is taken outside, we will get g into the partial derivative of f with respect to I cap plus the partial derivative of f with respect to y into j cap. That is equal to f into, what is this expression? It is the gradient of the vector g, gradient of the function g. Therefore, f del g plus g into this function is gradient of del f. Therefore, gradient of fg is given by f into gradient of g plus g into gradient of f. This rule is called product rule for gradient function. Similarly, we can prove the quotient rule, the sum rule, the difference rule and the scalar multiple rule. Just you try with those properties. Okay, we can conclude this section. We can discuss more properties and more questions in upcoming videos. Okay, thank you.